So I want to talk through a couple of important ideas. Let me make sure I'm actually recording the board. Board and McKay's face. Man, everyone online is going to be so lucky.
Ain't nothing that a beer can't fix.
Oh my god.
Oh, that's exactly what I want on YouTube.
He's cutting
for
that
my
straight
classroom.
out. He's cutting that straight out.
He's a fireball.
For anyone that watches online, roll Tide NASCAR. That's all I can say.
Praise the race.
All right.
Hell,
That's
So,
gonna be so much cut.
let's talk through. What'd you say?
I
thought
said there's
right.
gonna be so much cut from the case.
I don't know. Let's look at numbers 1 and 2 here. So x plus 1 equals x plus 1.
You went real quick.
Always gonna be the same.
Always going to be equal, right? However, I want to start to acknowledge, so always equal. So what would the solutions be?
Any negative infinity, positive.
There we go. So that's something I want to point out is the solutions are anything or negative infinity to infinity. So what notation is this?
Interval.
Interval notation, right? From a minimum up to a maximum. Is there a way to do this answer in maybe set notation? There's no reason, but sure. Okay, so let's think about set notation. Well, the reason is we need to be comfortable with them. Okay, so we always start out with curly bracket.
X.
So the set of x when
X. That's the element. Integers. Real numbers.
which one?
It's the real numbers. 'Cause it
Real
combines
numbers?
everything.
Brady, what do you think?
Are real numbers combined.
Linnea? Real numbers? Okay, so why is it real numbers and not just integers?
Because it could be real numbers as negatives, and decimals, positives.
So you're indicating that those decimals can also be solutions here.
Mm-hmm.
Okay, and that's what I do want you to recognize, right? Integers are just like -5, -4, -3, up to the positive infinity and negative infinity, but we're missing all those decimals. This hits all the decimals as well. You said put a comma?
No, I'm just saying,
Do we need to?
yeah.
Okay, so what comes after the comma?
Mm-hmm.
Any ideas?
Negative infinity, positive infinity.
Well, that just sounds like interval notation.
Oh, I'm not.
You can do this.
Yeah, that.
Although I will point this out, that's unnecessary. Because if we're talking about all real numbers, what are we talking about?
Everything.
Everything from
So
negative
that
infinity
no need.
up to positive infinity.
Mm-hmm.
So if there's no restrictions on the real numbers, if it is truly every real number,
There's no need for
Just
X.
close it up.
You would
That's
just- end after the all real number symbol.
Really?
I would.
X is an element of all real numbers.
What?
Fun fact, huh?
Go for it.
Well, I was going to say fun fact. Do you know what I could put here instead of this vertical line to define what X is?
An X.
No.
A horizontal line.
No. Listen to the question I asked. What symbol could I put here to define what X is?
Equal sign. Yeah.
No, you said it earlier. I heard some type of comma thing.
Oh,
colon.
There you
colon.
go. That's why I said
There we
comma.
go. A colon can also go there because I'm defining what X is. That's actually a very mathematical
Boy,
thing.
got that right? Follow me. IG.
Alright, so I typically, when I write it, do a vertical line. If I'm ever typing it out though, I will use a colon because that's much easier to put when typing. Yeah.
Lowercase L.
You could. I've thought about that. I feel like it's slightly cheating though. It's not an L, it's literally a win symbol, W-H-E-N. But I do want y'all to notice like those different ways to write that. Okay, so x plus 1 is equal to x. I think everyone realized that this was what?
No solution.
No solution, meaning that it will never be true. Now, you say no solution, and so I want to, somewhat using this as a way to introduce some notations that we may not have seen before. So I would write these kind of notes down about the notation and get the practice in with the notation. So you say no solution, right?
Mm-hmm.
You can literally write out the words no solution, but any guesses what the symbols might be for no solution?
It's a 0 with a line through it.
Okay? This right here is called the null set. This right here is the same thing as doing this. Notice
I haven't
what's
done-
inside of this set?
Nothing.
Nothing. So what are the solutions?
Nothing.
Nothing.
I haven't done this since Algebra 1.
This,
That's my
this
favorite.
symbol, the null set, is this symbol right here, just a little bit easier, right? So this is literally the set notation with nothing inside of it, meaning there's no solutions. That's the same thing we have right here. They're equivalent to each other.
Got
Which-
that right too?
Yep,
Follow
you
me.
know. So
He's really trying to get the answer.
notice how I'm using the three horizontal lines, meaning they're equivalent
Yeah,
ideals.
that's him.
Equivalent, yeah. Okay. And so one thing I want to point out, because I keep asking this question, I want you all to always think about this. Is it always true, sometimes true, or never true, right? This was always going to be equal, it was always going to be true, so solutions were there. This was never going to be true, so no solution. So what would we say here? Always, sometimes, or never true?
Only true for 0.
So always, sometimes, or never?
So,
Sometimes, right? When I say sometimes true, that means that there's only like one or maybe two solutions for it. So you can just leave it as x equals 0, but how would I write it maybe in set notation? Be the set of what?
X, 0,
You-
0.
You could just say the set of 0.
Oh,
Yep, yep. So notice like you don't have to do the x when x is an element of or anything like that because we're not talking about more than one solution. We're talking about one solution. You can say the set of x when x equals 0, but that seems a little excessive, doesn't it? And then it's like, yeah, that'd be dumb, Mr. Taney. Like, why would I do that? Exactly. We would just say either x equals 0 or the set of 0. Okay. You know we have like 5 minutes left, right?
yeah, I'm just getting there.
Okay. Because we're gonna finish going over number 2, and then we'll wrap up there. Okay. So now though is where I want to pull on some really important ideas that I heard both the groups I think actually talking about. Everyone agreed that these two equations were going to always be true, correct?
C.
So then the solutions are
Equivalent.
the solutions.
Infinity.
Negative infinity to infinity, or in set notation, the set of I mean, it's the set notation, so it's the set of x, right, the variable, when
Oh, he about did the dots.
X is real. Element is real.
are the real numbers, right? So it's always true, those things are there, but Braden, you hit on the most important idea. Why are these, were these equations always going to be true so that their solutions are negative infinity to infinity?
Because they're equal.
The equations are equivalent, or let's say it this way, the expressions,
Yeah.
right, in the equation are equivalent. What do we mean though by equivalent?
Same. Yeah, equal but different.
Okay.
Different but equal.
Different but equal, so they look different, but they're effectively the same, right? So look different, effectively the same. And that's that idea of equivalency goes honestly throughout mathematics. And so it's something that you want to hold on to. When I took a class this summer, so I'm working on something called an EDS, an Education Specialist degree. It's like above a master's program. But when I was doing that, we started talking about this idea of equivalency a whole lot. And honestly, it changed the way I think about mathematics, and it helped me understand math because I started to look for parallel ideas across mathematics way more. You start to look for ideas of equivalency, it will help a lot, not just in mathematics but in life, because you're going to start to look more for how things are similar than just saying that they're radically different. The reason I bring that up is because I feel like people, especially in the US and especially on social media, we're consistently arguing and fighting and bickering with each other in a really unhealthy level because we're constantly looking for how things are different when there might be a lot of similarities there, and we could really fight for commonality. That's a small thing, but I did want to mention that. So that's why I keep bringing up this idea of equivalence. Now, looking at these last two equations, and we'll end here. Okay, so we had no solution here. Did y'all agree no solution?
No.
No, what'd y'all say?
If x was 1, then it would be equivalent.
3 times 1 is 3. 2 times 1 is
2.
2. 3 plus 2 is?
5.
Oh.
Number 4 is not.
You think this one's no solution as well?
100%.
No, if you made x 0.
How? To 3.
What's 3 times 0?
0.
2 times 0.
0.
0 is equal to 7 times 0?
It's a jump.
So here's what I want to point out, right? Now, so listen, the idea of equivalent expressions is actually pretty easy to pick up, and I do also want you to note that there are different ways to approach this, right? Most people recognize right away here that that's just 5x and that's 5x, so those are equivalent. Y'all approach this one algebraically very differently. Linnea, I believe you just distributed here, right?
Mm-hmm.
And so 3x plus 2x is equal to 3x plus 2x. That's very true, isn't it? Those are literally now the same exact thing, so there's infinitely many solutions. Whereas Alan and Braden, I believe you all divided by x.
Yeah.
Both sides.
Now, one thing I want to clarify, I want you to be careful of is, you're dividing by x, so it's canceling out this entire multiplication. When you divide by x over here, you have to distribute that division.
Yeah.
That's the only reason why it also cancels here, but 3 plus 2 is equal to 3 plus 2.
Yeah.
We are running out of time. Remind me, I want to talk about 2 more things here. We'll pick up there tomorrow. I know you're surprised that I can talk about 2 more things. But hopefully we learned a little bit about equations and the idea of equivalency. We'll pick back up heavily with number 3 and use the rest of the period tomorrow to talk about those. As I said, no homework. I will definitely have review homework for you tomorrow. You had 2 days without it, okay? Cry me a river.
Hey, that's actually a song.
I know, that's why I referenced it.
I'm probably one of the only few people in here that knows that song.
I would hope most people know that song.
It's a good song.
Who is it by?
Oh my gosh, what was his name?
I have no clue who it was by, I just know
Justin
everyone.
Timberlake?
Yes.
Yeah, I know this
Because
song.
I have like several of his.
I definitely don't know that song. Or not, I don't know it by him, or didn't realize it was by him because I don't listen to Justin Timberlake. But
Sure.
it's okay.
Sure. I
No,
believe that.
literally.
Really?